So remember, we don't want something that's just going to be looking at these positions, but we want something that's going to be looking at the orientations and the twist. This is where it's important to go back to your reference material. If you look at your reference material, you'll notice that when you look at the forearm of what happens, when somebody rotates their wrist, the skin doesn't just rotate 100% with the upper arm or 100% with the hand. It actually twists along the forearm. Um, in the real world, this is because the person has a radius and an ulna, and when they twist their hands, the radius and ulna twist about each other. The radius actually rotates about, the ulna kind of stays in place and just sort of moves out of the way. But we can simulate that. We can simplify that whole solution by doing something like this, basically creating something that twists along the joint. And the same thing happens in the upper arm as well. Both sections, the upper arm and the lower arm, twist based on their orientations. So what we want to do is come up with some type of system where we have segments that look like this, where the top control sits at one point and the bottom sits at another point, and it stretches and twists correctly in between. So that way we can say, all right, shoulder's going to be up here, elbow's going to be there. Align something that looks like this correctly and twist correctly so it lines up. Do the same thing for the lower arm. And by doing that, it doesn't matter what type of system we have, whether it's forward kinematics, inverse kinematics, or Googleplex kinematics. As long as we say the shoulder's here, the elbow is here, and the wrist is here, and align yourself appropriately, we can do whatever we want. And that's a very freeing thing to do. So how do we do this? Well, take a look at what this segment looks like. Does it remind you of anything in particular? It should. It reminds me of the torso rig. It looks just like it. You have a top, you got a bottom, and you got a twist along it. So we can adapt the Spline IK rig that we're using for the torso to make it work on the arms of our characters. And then using this, we're just going to hook up the top and bottom to the various parts of our arms, and they should twist correctly along the joints. Okay? So let's take a look at how to create a twistable segment. Alright, let's go ahead and create a new scene. File, new. Cool. And what we're going to do is create a twistable arm segment. So, let's go to our front view. Like so. There we go. And we're going to choose Skeleton Joint Tool. And we're going to create a joint segment. And we'll just go, hold down X for grid snap, and go from there to there. Joint segments, woo! And then we will split those segments. Let's split them into, say, 5. Doesn't really matter. You pick which ones you want. We now split the segments up, and we're going to rename all of the joints. Okay? So, if we go to our outliner, and we go in here, we can do what we've been doing before, where you type in here and you say, foo, blah, and then foo 2, foo 3, etc. But that's kind of a pain. So I'm going to show you a script that you get called hash rename, where you select all these joints, you go up here in the shelf, click on rename, and we can type in our new name, seg underscore hash underscore joint. And what that does is that replaces the hash mark with a number. So seg 1 through 6. There we go. We can also do foo underscore hash 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 underscore bob, and it'll do 0, 0, 0 and replace them that way. Pretty cool. But we'll keep it simple, just like that. Okay? Now, let's go ahead and add a curve that we're going to use for this. We're going to create an EP curve, and we'll choose create because we need a curve for our Spline IK system since that's what we're going to be using. We'll set it to linear, like so, and we're just going to go ahead and snap. So there and there. So there's our curve 1, like that, and we're going to rename it. We'll call it seg underscore curve, and we're going to create an IK handle. So we'll go to skeleton, IK handle tool, or IK spline handle tool, go to the option box, and we're going to say turn off auto create curve because we're going to use this curve that we've already got. And we're going to turn off auto parent curve. We don't want it to be parented. And we're going to select seg 1 joint and seg 6 joint. And then select the curve. And it will automatically create that for us. And then we'll rename the IK handle to seg IK handle. See how I'm renaming as I'm creating? Makes it very easy to keep track of what's going on. I'm going to keep harping on that. You got to rename. Rename your stuff, mister. Keep renaming. So we've got our curve. We've got our joints. We need some way of controlling this. So, I can go like that. Since we're going to be hooking this up to a joint system, we might as well use joints to control it, just to keep things simple. So, we'll go to Skeleton, Joint Tool, and we're going to create two joints that kind of reach one from there to there, there to there, just like that. And we're going to call this one Seg Start Control. And this one's going to be Seg End Control. Okay? And then I want to turn on the local rotation axis for each of these joints so we can see what's going to happen and how we're manipulating the twist. So I'll select all those and go Display, Transform Display, Local Rotation Axis. We can see what the twist is doing. And we're going to try another method for handling twist besides object rotation. Remember in the Spline IK system that we did for the back, we used the shoulder and we used the hips, and by looking at those guys inside the solver controls for advanced twist controls, we had been using, whoa, haha, crazy scroll. With world up type, we were using object rotation and up, or start and end. Instead of using that, we're going to try something else. We're going to basically say, you know what, try and use an up vector to control this. And we're going to use an object, kind of like the elbow control, to do it. So it's going to make it a little bit easier to control. So we'll create a locator, and we're going to place it right here. And it's going to be basically just up above this little section right there. And we're going to say aim at that. Okay? We're going to do one for each actually. So we'll have a start, seg, loc, and we'll put it there. And we'll duplicate it and put another one here, and we'll call it end seg loc, like that. Actually, you know what? Let's be consistent. Seg start. Notice that everything else is named starting with seg, end loc, like that. Keep our consistency there. It's important. Very important. So we can see what we've got. Like that, we've got a locator here, we've got a locator here, we've got twist along there. So let's go to our advanced twist controls on the IK handle. And we're going to set our attributes so they look like this. Enable, object up, start and end. Positive Y is fine. And we're going to choose, for the world up object, it'll be seg start loc, and the world up object 2, seg end loc, like that. And now watch what happens. If I take one of these and I move it, see how it twists along there? We're using these locators just as we did on the hand to control what axis this is going to orient along, or how this is going to be aiming, which is pretty cool. And we're just going to go ahead and parent these locators directly under these controls. So seg start loc will be under seg start control, and seg end control will be right underneath that one. So if we take these and twist them, the whole thing will twist. If we take the end control and twist it, twists like that. Not bad, right? Cool, so far so good. But we still need to control the curve. So right now, if I do this, the curve isn't doing anything. We want to control it. If we just parent the curve to this, it'll work fine that way, and it'll work fine when we rotate it. But if we were to take the end control and stretch it out, the curve won't do anything because it's not deforming. We need to tell the curve to deform and follow the point or the start and end. So we're going to go ahead and create a couple of clusters. We'll go create deformer cluster for that side, and we'll go back to this one, hit F8 to get into component mode, select CV, create deformer cluster, like that. We'll take this cluster, we're going to parent it to the start, take this cluster, and we'll parent it to the end. Now, when I click and drag, the whole thing moves around with us. If I grab the end, it stretches along. like the curve stretches anyway, and it orients correctly, which is sweet. So now that we've got this kind of working, let's take a look at what happens if we're using this. Let's pretend it's an upper arm. Let's say if I take my arm and I bend it down like that, so it's at my side, and if you do this with your own arm, and you kind of twist your elbow out, like you kind of raise your arm so it's at your side, and you twist it around, so it's kind of going in and out, you'll notice that your shoulder itself doesn't seem to be rotating. It looks like it's twisting along the length. You kind of get this sort of result, like that. But what happens when we're animating is we don't actually think like that. We don't think, okay, I'm going to break my elbow and bend that out. If this is a little bit tough to understand, let me go ahead and create a little extra joint here just so you can see what I'm talking about. We'll just translate that out. Okay, so pretend this is the arm. We'll bend it down. Now if I were to twist my arm, I wouldn't go down to this joint and start twisting it. Let's change the rotation order here real quick just so we can see what it is we're talking about. I wouldn't go down here and start doing this, right? I would actually be doing all of my twisting up here. But notice what's happening to the joints that are following along here. If we look at what's happening with the Y and the Z, when I rotate down like this, we get the proper twisting along the arm. But when I rotate this one, we're not getting the proper twisting. And the animator isn't going to want to twist the arm by going down here. They're going to want to twist the arm by working with the upper arm control itself and twisting that. So what we need to do is tell this arm somehow to not twist along the geometry. Basically we want it to bend up and we want it to swing this way, but we don't want it to twist like that. We want it to twist by simulating that. So how do we do that? It's a very good question. I'm glad you asked. Let's undo all that so we don't have that joint there anymore. So how do we go about doing this? Well, if we take this arm and we rotate it down and we twist, we got those Y's twisting 100%, which we don't want. The reason for that is this locator, the start locator. Remember, this is the thing that controls the twisting along the joint here. If we unparent that from the start control, we'll get the kind of twisting we want. That's exactly what we want. However, if we then rotate this, it still kind of works okay. Sort of works alright. But watch what happens as soon as we twist, like, as soon as we bring this up past that value, boom, the whole thing flips over. See how the Y's are flipping? We don't want that. So how do we solve this? We want this twist to stay stationary the way it is, but we want the joint to, or the locator to be moving when we rotate up and down and when we swing. We don't want it to stay stationary the whole time. So what are we going to do? We're going to create a secondary joint that's going to follow only the Z rotation and the Y rotation and twist and then not twist, so that when we bend the arm up and down, the locator will follow correctly. When we swing, the locator will follow correctly, but when we twist, it's not going to move. Okay? So let's undo until the arm is back where it's supposed to be with the locator parented correctly. Okay, so it's right there. So now what we're going to do is we're going to duplicate the start control, and then we're going to delete all of the children. Goodbye, children. You have been deleted. And we're going to rename this seg start aim, because this is going to be our aim control for the twisting. Okay? And now we're going to connect the seg start control to the seg start aim, so it's going to follow exactly the same. So bring up the connection editor, Windows General Editors, Connection Editor. Choose Reload Right for seg start aim, and I'm going to choose to not show non-keyables because it's going to be easier to find stuff. So then we're going to select seg start control and click Reload Left. And we're going to connect the rotate Z and the rotate Y, because rotate X is what handles the twist. So rotate Y is going to drive the rotate Y, rotate Z will drive the rotate Z. Boink. And now we want to parent this locator, start locator, to seg start aim parent. So now if we take seg start control and we rotate it down, notice this locator is following. If we swing it, the locator follows correctly. If we then twist, we get the proper twist along the arm, and the locator is not following, but it will still follow correctly as we raise it and swing it. And this is exactly what an upper arm does, except the upper arm doesn't have multiple joints that are broken and connected with connection things and stuff like that. It just works correctly because of muscles. But we are simulating it, and it is good to simulate. Let's do a save. File save scene as. It's always important to keep saving your work so you know where you're at, and you can always get back and try different things. We'll save this as ARM Toolkit 8. Alright, something that you probably noticed before is that when I grab the seg end control and work with it, the spine isn't stretching correctly. So we need to find some way to tell the curve to go ahead and stretch along with the spline. So to do that, we're going to use the Create Stretchy Spline button on the shelf. And that is this one right here. So go ahead and click on the seg curve, click on Create Stretchy Spline, boom. And here we go. We're going to make sure maintain volume is off because we don't care about that. And we're not going to worry about the world scale right now. We'll be dealing with that later. And click Apply. So now, if we grab the end control, it will stretch along with us and twist correctly. Sweet! And finally, let's just group this entire thing together to make it easy to package. So, select, because right now this is pretty messy, isn't it? So we'll select the seg curve, the seg IK handle, the seg start control, the seg start aim, and seg one joint. And we're going to group them. We'll call it seg underscore group. Now, we need to turn off inherit transforms for the curve, because if we grab this group and move it, the whole thing's going to wig out. And that's because this curve is getting double transformed. So we select seg curve, turn off inherits transforms, grab that, move it. Now that works correctly. Cool. And let's add some geometry to the segments to make it a little bit easier to read what's going on. So we'll select seg 1 through seg 5 joints, and we'll click on Add Geometry, like that. And there we go. We've got our geometry. And now we could actually save this in our library if we want, where we could then use this thing and say, okay, now we've got this joint system here. I can take the start, I can take the end, I can put them wherever they need to be, and I can twist them, and it'll all work correctly, and start using this as a way of mapping it to our FK and our IK systems. So let's go and save this scene as. We'll go into our library right here, go into Objects, and we're going to call this limb segment.ma, like that. Save. So now let's see how we can apply this system to an actual ARM rig. Let's go ahead and create a new scene, choosing File, New, Don't Save. And we'll create a joint structure that looks kind of like this from the front. Skeleton joint tool. We'll create an upper arm, a lower arm, and a hand. Like that. Actually, you know what? We don't need the hand. We'll delete the hand. We'll just create that lower arm there. Boink. And let's go ahead and name everything correctly. Oops. There we go. So we'll name joint 1 up arm, name joint 2 low arm, and name joint 3 hand. You can probably see where this is going because we've done that many, many times. And now we're going to import the segment that we have from before. So we'll choose Import and go to the option box. And we're going to say don't use any namespaces. Import limb segment MA. There we go. So we've got our limb segment right here. And we want to position the limb segment in the right place. So we're going to take the seg group right here, and we're going to orient it so it lines up with the up arm, and we'll position it correctly. There we go. So it's positioned in the right spot. And then we'll take the end control. So the start control there's the end. And we can move this around. We'll move it so it lines up with the lower arm like that. And then we're going to go ahead and attach it with constraints. So we need to attach it either with parenting or with constraints, and I think constraining in this case will be the easiest because it's going to keep it separate from the control itself. I mean, we can just switch back and forth between whatever we need. Okay, so let's select the up arm right there, and we'll select the start control, and we'll go constrain parent like that. Then we'll take the low arm and the end control and do constrain parent again. And now, if we take the lower arm and we bend it, let's go ahead and change our rotation order on the lower arm because we know that that one isn't going to work. So we go like this. We can twist it, and our arm will twist correctly. We can grab the upper arm and bend it like this, and we can rotate. And notice how we get the twist correct. We can swing, and the arm's working correctly. That's great. Let's go ahead and bring in the segment again and make a lower segment. So go File, Import, go to the option box, and we'll just import like this, and we'll choose limb segment again. Now we've got limb segment seg group 1, and now we'll go ahead and position this so it's moved into the right spot just like we did on the upper arm. We'll grab the lower, the end one, and we'll move this, oops, so it's going to be in the same spot as the hand control right there. Bada boom, bada bing. And now what we can do, just to keep things simple, because we could constrain it the same way we did the other one, but when you start constraining things, the scene can get slower. So since we want the limb segment, the first one, to actually follow what the end is doing, we're just going to parent it like that. That way we know they'll be in the same spot always, and we don't have to worry about things slowing down due to too many constraints. Okay? Then we're going to take the end control like that. We want to make sure that the hand constrains that. Constrain parent like this. And now we can control everything with the upper arm, the lower arm, and the hand. So we can take the lower arm, we can do this. We can take the upper arm, we can bend that down. We can twist, and we get the proper twist on the upper arm. We can take the hand, twist that. We get the proper twist there. We can swing the lower arm and get whatever we want. We can twist it if we want. We can bend it out this way, and you'll notice that we're getting the correct orientation all the way along the arm based on whatever these 3 points are doing because of how we set it up. So we have a very, very robust arm system now where we can animate either forward kinematics or inverse kinematics, and whatever we've got is going to follow through correctly on our skinning and with the result arm. Okay? So that is super useful. Let's go ahead and save this version. File, save scene as, arm toolkit number 9. Woohoo! Alright, so we've got an arm rig that works, but what is next? Shoulders. We need to figure out how we're going to handle the shoulders for the character. Thinking about the type of motion we expect the shoulders to handle, it's all about being able to shrug, drop the shoulders, stretch forward, pull the shoulder back. There's tons of attitude and tons of emotional control that you have with the shoulders, so it's really important to make sure that they work very, very cleanly and very easily for the animators. I like to also use shoulders to help cheat arm positions based on the pose. Sometimes, simply because of the angle of the camera to the character, it's necessary to push a shoulder past what would normally be a breaking point in order to achieve the pose required. Sometimes you just have to pull it out a little bit. So if you think about what's required, there are two possible methods for manipulation of the shoulders. We can either rotate them, like so, or we can translate them like this. And these little images basically mean, this black line, or this line right in the middle, is the rotation. Here's the black one right there. What this means is this is the position of your shoulder using rotation. You go up and down. This is the possible, or these are all the possible positions of your shoulder using translation. With rotation, you're able to achieve a very specific range of motion, a rotation out from a point within the top of the shoulder, on top of the torso. With translation, your range of motion is much broader and can be exactly what the animator needs for the shot. So which one do you use? Personally, I prefer translation, mainly because I want to have absolute control. I don't want to have to worry about the shoulder going, only being able to rotate within this axis right in here. Part of that is because, let's say I do a shrug. If I have the arms straight down and I shrug, notice how it moves back a little bit? That means the arm might actually move backwards and end up being inside the torso, which I don't want. So, with a translation, I can just translate it straight up and get exactly what I want. So let's go ahead and create a shoulder joint for our rig. We'll go into a front view and choose Skeleton Joint Tool. And we're going to create a joint that looks like this. Like that. And we're going to name it Shoulder and Shoulder End. And we're going to create Stretchy IK for the shoulder joint. And to do that, we'll click on the Create Stretchy IK button, which is right here in the shelf. Click on that. Choose the shoulder, shoulder end. The options that we want to set are a single chain solver, scale method as translation. Apply that. And as you know from the second DVD, that automatically creates a start and an end control and the distance for us. And it rigs it all up so that when we take the end, we move it and the shoulder moves correctly. Then we're going to group all of these little bits together. So we're going to take the upper arm and the segment group like that, and we're going to group them. We'll call it up arm group, like so. And we want the pivot of up arm group to be at the place of the shoulder end, where this joint is right there. So you can do that by selecting shoulder end, select the up arm group, and then there's a copy pivot button that you get. You do that, it'll copy the pivot from the first thing that you had selected and copy it onto the second thing. So now the pivot for the up arm group is here as opposed to being down there. And now we'll constrain it. So we'll select shoulder end, select up arm group, and we're going to go constrain point. Now the reason we're doing a point constraint is that we don't want the upper arm to change its orientation when the shoulder moves. If I move the shoulder up, I don't want the upper arm to bend upwards like that. All I really want is for it to move itself so it stays aligned with the shoulder, but then is rotation independent from what the shoulder's doing. Okay? So using that, we now have a translation-based shoulder control that works with our arm rig, and that's basically all we need. We've got a shoulder. We could parent geometry to it if we want. We could just grab the end control right here, move that around. We've got our IK rig, or sorry, our FK rig here. So upper arm, could drag that down, bring this over, grab the upper arm, twist it. Maybe go that way. Like that. And then we can grab our shoulder control right here and just move this up and down, and it all works correctly. Cool. So what have we done? We've taken a look at the various animation requirements that we've got for our scene. We have an FK arm. We've got an IK arm. We can allow for stretching on both the FK and the IK. We know how to lock the arms down, and we've taken a look at different shoulder controls. We also now know how that we can blend between by creating a result arm. So the animator can choose if they want an FK arm system or an IK arm system. They can choose whatever works best for their scene and for their situation, and they can blend between the two to create the result arm to make it look exactly how they want. So this is cool. We've tried a whole bunch of different things, and our next step is to actually put it on our official biped arm. Okay, so let's go ahead and open up the latest version of JJ by choosing File Open, because now it is time to add the arm. Oh yes, sweet. So if you grab JJ Rig version 2, we'll open that up. Don't save. Now the first thing we want to do is add the arm. So if we look under JJ Group, you can see here's this geo right here. We'll go ahead and grab the left arm and work from there. I'm just going to unparent it. Ta-da! And there it is. Left arm geo. Let's move it up to there so we can see it. And I don't know what group 1 is doing there. We'll just get rid of it because we do not need it. Alright, so we've got our arm here. And what we want to do is break apart the arm geometry. Sorry, geometry. We want to break apart the arm geometry in a way that makes sense for how we're going to bend the arm and how we're going to work with it. So the best thing to do is take a look at where we think our joints are going to be and then break apart the geometry that way. So we know that we're going to need a joint in the elbow. We're going to need one there. We'll need one by the wrist. And we're going to need one up here in the upper arm for the shoulder, or for the upper arm. And we'll probably be putting a joint in here as well. So let's go ahead and break this up into little geometric pieces that make sense for what we're doing. Okay? So we will go and hit F8 to go into component mode, and then hit this little button up here to work in faces. And we're going to select our faces. So if we go to a front view, and we'll choose our little lasso tool here, and I'm just going to pick like this. Let's take a look closer, make sure we've got everything we need. Oh, there's a couple in here we want to grab. And that one as well. Spin around. Are we getting the entire arm? Yep. So there's a line right along there you should see we can grab. Same thing with the shoulder. We want to grab that. And now let's go down to the hand control. And we'll grab that as well. Make sure we've got all the little bits. There's that one. Just spin around in here until you've got everything you want. That little bit there. There we go. That looks like everything, doesn't it? Sweet. Alright, so we've grabbed all the bits of all the faces that we want, and then we're going to extract the mesh. So we're going to go to polygons, we'll go to mesh, and extract. Just like that. And what that should do is break things up into 4 different pieces. We should have the shoulder, have the hand, the lower arm, and the upper arm. Just like that. Let's rename them. So this is going to be L, shoulder, geo. It's going to be L, hand, geo. This is L, low, arm, geo. And L, up, arm, geo. Just like that. Easy to see what's what, and we know exactly what we're doing. Okay, and I'm going to delete history on this. Modify, edit, delete by type, history. There we go. Okay, now we want to create a joint that fits right in through here. Now, one of the things that I like to do in building my joints is I like to build them straight out, just because it means it's a lot easier for me to know what is 0 with a joint. And the animator knows if they set their rotations to 0 on their joint, it's going to be flat, always. I'm a real, I just get really picky about it. I hate it when a 0 value on a joint is something like this. If we go boom, boom, and that's our 0 value for this joint, that drives me crazy. Whoops. Get out of component mode. That drives me crazy because there's no consistency there necessarily. I have no guarantee that all the arm joints are going to be at exactly the same angle. So if I want to transfer animation between characters, or if I want to copy animation from one side to the other, or anything like that, it's a real pain in the butt because I just don't know that every character is going to have 0 exactly at this angle. So for me, what I like to do is make sure that when I create the joint, I click right here for the upper arm, hold down shift, and then click and drag somewhere around here for the rest of it. And that way I know that it's absolutely horizontal, and whenever the animator resets it to 0, it's going to be flat. Flat, flat, flat. That's what I want, either flat or straight up and down. None of these angles. None of that stuff. Alright, let's change the display here. of the joints to make them a little bit smaller because this one's pretty big. And there we go. But that being said, we know we need this joint segmented into 3 different sections, so we will segment it using the split selected joint tool to 3. Okay. And that being said that this is flat, but how do we actually line it up with our geometry? Well, we just pick the geometry, move it. No, I'm just kidding. That would be a real pain, wouldn't it? That would suck. No. What we do, it's actually pretty simple. We take this joint and we just rotate it down and we align it with the geometry, just like that. You can come in here and you could say, well, that's minus 19 or whatever, type whatever values you want, or just get in and move it really, really closely until you get to line up. Then we go and we adjust these joints until they line up with the cuts in our geometry, like that. Pull that one back a little bit. And we check in our perspective view to make sure that they are in the right spot, which in this case, they weren't. But now it looks like it's pretty close. So we go like that. And there is our joint, and it's all lined up. Okay? Perfect. Sweet. Okay. Let's go ahead and rename these joints so they make more sense to us. So joint 1, this is going to be L up arm. Joint, this one here is L low arm, L hand, and the last one is L hand end. Now, most of the time we're going to be working with our joints flat, but every once in a while you may want to get back to this specific angle, and if the value isn't something easy to type in like negative 19, but negative 19.245712569A alpha gamma quadrant foop whatever, you'll want to be able to get back to that at some point. So if we go into the attribute editor, you'll notice that there's this presets button over here. So if we click on that, we could save joint preset. So we'll go there, and we're going to go ahead and call it L up arm bind or something like that. Save attribute preset. Now, if I rotate this and move it anywhere else, and I want to get back to that, I can click on the presets and go down to L up arm bind, and then I can either blend it in like 25% of what it currently is, or I can go L up arm bind replace, and it'll go right back to that value. So the presets are pretty cool for being able to save almost like poses. It's almost like a little pose library for every object that you've got. Pretty handy, or you can just create a button and put that up in the shelf. However you want, it's up to you. Okay, so let's go ahead and parent the geometry to the up arm. So we'll go L up arm geo is going to be parented to L up arm. L hand geo will be parented to the hand. Shoulder geo we're not going to worry about right now because we don't have a shoulder joint. And low arm geo will parent to the lower arm. Woo! There we go. Now we can set this back to 0, and the arm moves to the correct spot. Now we can work with it and create all of our FK and IK and everything like that, and we know that we can always get back down to the default bind pose if we absolutely need to. So let's go ahead and actually create a shoulder joint for ourselves, considering we don't have one, and it might be kind of important to have it. So if we go to a front view again, and we go skeleton joint tool, we'll just go ahead and put it, let's say, around here, like that. And then let's go ahead and switch to a perspective view so we can move the joint back. About there. And if we want to actually make sure that the joint lines up exactly with this joint, a good little trick here is if we go show polygons, turn them off, and then I click on the TZ, like this, so I'm moving it in Z, hold down point snap, click with the middle mouse button at this point right here, and it'll snap to that joint. See how now it's lined up exactly? That's a fun little trick. Cool. Turn that back on. We're not going to worry about connecting the two yet. We're just going to go ahead and create that, and we'll call it L shoulder, like so. But, you know, what good is a shoulder joint if it doesn't have any end, if it doesn't have a child? So, in order to make sure that we create one that's going to be exactly the same as this up arm joint, just to keep it kind of interesting, I'll show you a way of doing that. We're going to duplicate the upper arm, delete all of its children, and then we're going to instead parent this upper arm to the shoulder. So now we've got a joint that goes right across and ends up in exactly the same position and orientation with all the exact same values as L up arm, like that. And we're going to just rename this to L shoulder end. Now you could have created this automatically by clicking on, when you created the joint, go shoulder to that one and just like go bink bink to create it. But I wanted to make sure that this end joint was exactly the same as the up arm joint. And the only way to really do that is to either copy all the values or duplicate it. So instead we're just going to duplicate it. There we go. Now before we get really going here, we want to change the rotation orders on these joints based off of what we had already discovered. Mainly because we're going to be duplicating these joints and creating the FK control and the IK control and all that sort of stuff. So before actually going ahead and duplicating and then having to change the rotation orders later, let's just do it now to make sure that we have our joints set correctly with the rotation orders. So remember what they're supposed to be. The upper arm was fine with the XYZ. If we go to the lower arm, remember we wanted to make it so that when you bent the arm like this, you could go ahead and break it and go up and down from there. So our rotation order needed to change, and it was going to be XZY, like that. So we can do this type of stuff. And the wrist was going to be ZYX, like that. So it could orbit and bend. There's 3 different rotation orders on the arm. You don't see that very often, do ya? Well, you should. It's a good thing. Let's go ahead and save this at its current state. We'll save this as arm rig version 1.ma. And there we go. Now we can continue on. Now we're going to do something that's going to totally blow your mind. You're going to go, what? That's crazy. I want to talk a little bit about joint orientation. So we know our rotation orders are correct, but what about the joint orientation? Well, what does that mean? What is the joint orientation? Think about it this way. The animator is going to be manipulating attributes to be certain values. They're going to grab the lower arm and they're going to bend it and straighten it, and they're going to do this. Once they start working with their animation curves inside the graph editor, they're going to be looking at specific values. For example, when they go ahead and rotate the rotate Y, they're going to be thinking how it's actually bending the arm. And when you bend the arm, you think about that concept. I'm going to bend my arm, and you want to say, I want to bend it 90 degrees. You would expect that if you set the value of the lower arm to be 90, it would look something like that, right? Or if you're going to set it to be 45, it would look something like that, because that's what direction you're bending. And if you were going to bend it backwards, you would think, I'm going to bend it negative 45 degrees, or negative 90, something like that. But look at what's happening with our rotation values. When we bend forward, our rotation values are going negative. That, in and of itself, can be confusing for the animator. We want to make sure that the values that they get over here, when they manipulate something, make sense for what the action is that they're doing. This way, when they go and they start manipulating things in the graph editor, it's a lot easier for them to understand what's going on. Okay? So, let's go and see if we can actually change the way these joints work so that the bending and the lifting and the twisting all make sense. So let's see how we can actually change this. If we go to, with the lower arm, and we go display, transform display, local rotation axis, our old friend, we could see how the axes are aiming along the joint. See how the y-axis is aiming up? Well, if we have it pointing down, imagine this is upside down. Well, imagine it's not upside down, but pretend this is right side up. If we go like this and bend it forward, we'd have a forward value. So that's what we want to do. We want to change this axis so the y points down, so when we rotate a positive value, the arm goes forward instead of backwards. So how do we do that? Luckily, there's a tool in Maya to do it. If we go to the skeleton tool, and we go down to orient joint, and go to the option box, there's a dialog here that lets us change the joint orientation. So as a refresher, just so we talked about this in class 2, but it's a confusing concept, so let's make sure that everyone understands what's going on. The first value here in the orientation, the first letter is the axis that you want to point down the joint, right? So because we want x to keep pointing down the joint, we know that our orientation either has to be xyz or xzy. The second axis here, or the second value, is the axis that you want to align with whatever your secondary world axis is. So in our case, we want z to be, if we take z and we flip it, boink, going that way, then we could say, for example, with xzy, we could say we want z to point along negative z, and that would point that way. Since we're concerned about y, we could also go to the x, y, z option and take that and say, well, y is going to point negative y and go down. We'll see what happens if we do that. Apply. Ta-da! There we go. So now, when we bend this, we get a positive value. See how that works? Yay! Does that make sense? Remember, first value is the axis that aims along the bone. Second value is going to align itself with whatever world axis we specify here. Piece of cake. So I know this seems like a very, very minor thing, but it actually is rather important to figure that out, and to get that set correctly for the animators. If they don't notice it, then you've done your job. Alright, let's turn off the local rotation axis so we don't have to worry about that, and we'll save our current version as V2. Always important to keep saving along the way here. You want to make sure you don't mess up and do anything silly. Okay, we now have a joint structure that can be used as the basis for our FK and IK control systems, but the geometry that we have is just sort of parented under the arm. So let's go ahead and create the twisting segments for the arm using that twisty segment thing that we talked about earlier. And once that's done, we'll then create the FK and the IK arm and figure out how to get the animator to decide which control is going to affect the resulting arm. Now, instead of actually going through and creating the twisty segment like we did before, where we created the joints and broke it up and added the spline IK and all that other stuff, there is a script that you get which comes with the DVD to make it easier. So, we'll select the left up arm, and we'll click on the Create Twisty Segment button. And what this lets you do is actually do all of the, basically everything we did earlier, but all with one button click. So, we want to enter a prefix for the entire structure, and we will call that L up arm, because this is going to be the L up arm twisty segment. We're going to choose 4 segments because that should be enough. We don't want to add any geometry because we'll add that ourselves later. We don't want to preserve volume. We do want to deal with world scale because remember, we need to be able to take this entire character and scale it up and down, and etc. And we're going to choose all underscore anim as our node. And remember, in part 2, we had added a global scale attribute to all underscore anim so that we could scale the entire character up and down. We'll choose that and click go. And what that does is creates a group called the L up arm group. And if we open that up, you can see here that it looks very similar to what we created before. You've got an up arm start control, and up arm end control, and there's clusters attached to those. You've also got the up arm start segment, and then that's broken apart into little pieces. And then you've got a do not touch group, which contains the start, the aim controls, the curve, and the IK handle itself. So if we take this L arm up arm start control and we bend it, you can see that we have those joints that go right down through there. Cool, so we'll worry about breaking apart the geometry in a second. First, let's go ahead and create the lower arm twisty segment, since we're already in creating twisty segment mode. So select the low arm, click that create twisty segment button, and we'll name the prefix L underscore low arm. Number of segments 4, everything else exactly the same. It remembers your previous settings. Click go, and there we go. We've got a low arm group and an up arm group. And the twisty segment creating is done. I'm going to change the size of the joints here just a little bit smaller so they're not too offensive there. Cool. Now that we have the joints, let's go ahead and break apart the geometry of the arm so that it can be parented correctly underneath these individual twisty segments. Okay, so first we'll start with the upper arm. Start with L up arm geo. Here we go. So select that. Click on the Add Plane for Cutting Geometry button. This is the same thing that we used in part 2 to cut apart the torso. We'll click on that. And then we're just going to position it right over here along this joint. Change the rotation to 0. Rotate that 90 degrees, like so. And you can see where it intersects the arm right there. We want to do the same thing for the rest of the arm, all the way through. So with that selected, we'll click on the Add button again, and we'll position the new one right here, just like that. And then we'll do it again for this one. So now we've got 3 of those for that arm, one for each of the segments that we created. And then we'll click on the Cut Selected Objects with Plane button, which will then create all those segments for us, just like so. So we want to parent each of these pieces of geometry to the corresponding segments that we've created. Okay? So we'll parent that one right here to, we go to L up arm group. There's the start segment. So we want to parent that one to the start segment here. We'll parent this one to the next, to that joint. We'll parent this one to this joint. And we'll parent this one to that joint. So now if we grab the start control and we bend it and rotate it, you can see that we get the proper rotation and bending for the upper arm. Cool. Let's do the same thing for the bottom arm. We'll select the geometry, click on Add Cut Plane, position it by that second segment joint right there, change the rotation to 0, 90, and Y. Then with that plane selected, we add another one, position that there, another one, position it there. We've got our 3 cut planes. With one of those selected, you break it apart, and then we're going to take that low arm geo. We'll go to the low arm group and take this first one right here, and we parent that to the start segment. Take the next one, parent that to the next segment, next one, parent that to the next segment, and this last one, and we parent that to that segment. Problem solved. Now we want to connect these segments to the arms, right? So let's select the L up arm right here and the L up arm start control, this one right there, and we'll go Constrain, Parent, and that will attach the start control to the upper arm. Then we're going to do the same thing with the low arm to the low arm end control. Constrain, Parent, like that. Now if we take L up arm and we rotate it, you can see that it affects that twisting control right there. Now we're going to connect the lower arm. Remember what we did before? Instead of adding an extra constraint, we just take low arm group and we parent it to the L up arm end control, like so. And now we're going to take the hand and we're going to parent constrain the low arm end control to that. Constrain, parent. So now, if we take the L up arm, we can bend it, we can twist it, we can walk down to our lower arm, bend that, we can break it, and notice how the arm's doing the correct thing. We can go down to the hand, twist that, notice how our forearm is bending correctly and twisting correctly. We can raise it, we can lower it. Everything's going to work exactly how we want. And the great thing is that all we need to do is control the constraints and how these groups attach to this L up arm, or we can just take this L up arm itself and control how it's constrained. Let's go ahead and save this current version. File, save scene as. We'll call it version 3. Now that we have a working arm structure, let's create the forward and inverse kinematic controls that the animator will use to control the rig. First, we're going to create various joint structures and hook them up to control the resulting arm. By setting up this relationship before we create the fancy FK and IK rigs, we can guarantee that the joint structures will drive the resulting arm correctly before we spend a lot of time getting the FK and IK rigs working. Imagine what would happen if we spent the next 2 hours getting the FK and IK rigs working only to find they didn't drive the resulting arm the way we expected. Well, we would go and have to start all over from scratch, and your boss would be like, "Why aren't you done yet?" And you'd say, "I don't know, it's crazy, I don't understand." And then he'd probably fire you. And you don't want to do that because you usually get free coffee at work, which is important. So, let's go ahead and get the two joint structures, the FK and the IK, created, and then we'll get the blend control working properly between them. Let's go ahead and start up with the FK control, the FK joint structure. Okay, so first, this is the resulting joint structure that we're working with, the L up arm, LO hand, and all that stuff. You know, we can actually delete these two geo nodes. We don't need them anymore. And let's go ahead and duplicate the joint structure. But instead of duplicating it the normal way, we're going to use this grep rename button that you get with the script, or with the DVD. So if you select L up arm and you click on that, you have a couple of options here. There's something called search for, replace with, and then duplicate, then rename. That's what we're going to be doing. We're going to actually duplicate this joint, and then we're going to search for L underscore in all the duplicates that are created, and we're going to replace it with FK, or sorry, L underscore FK, like that. Okay, and when we click go, watch what happens. Oops, forgot. It should actually be L underscore FK underscore, like that. Go. Now, it's automatically duplicated that object, then searched for L underscore with the duplicate and replaced it with L underscore FK for all of it. Isn't that easy? Much easier than typing everything and duplicating and renaming and all sorts of stuff like that. So, we've done that. We don't need the LFK hand geo. We can get rid of that because all we're looking for is these joints right here. Okay? And because we had actually set up the joint rotation orders and orients and everything correctly before, so let's go ahead and create the IK joint structure. Okay? So, we'll do the same thing. We're going to duplicate the FK joint structure that we've got. We'll use the grep rename button, and we're going to search for FK, and we'll replace it with IK. Make sure duplicate rename is on, click go, and now we've got the LIK up arm. Let's go ahead and save this in its current state again. Notice how often we save. It's important. You gotta save. Save that as version 4. Okay, so now that we have our FK and our IK joint structures, it's time to hook them up to the results arm so the animator can transition the joints between FK and IK. Notice we haven't actually set up IK yet, or set up any of our FK controls. We're just getting the joints working. And we're going to have this joint and this joint drive this joint, and figure out how we're going to actually blend between the two. Okay? So how do we make them control the result joint? Well, there's a couple of ways we can get the FK and IK joint to control the resulting joint. We can use constraints, expressions, blend nodes, all sorts of stuff. In this case, we're going to show you a method that you can use that might run faster than constraints, and it's called the blend colors node. This is basically a simple Maya node that takes two colors and gives you a resulting blend between them based on a blend value. For example, if color 1 is blue and color 2 is red, the output of the blend colors node will be purple. So how can we use the blend colors to drive joints? Well, the color 1 and color 2 are simply three values, red, green, and blue, and the output of the blend colors is also three values. So if you map red, green, and blue to X, Y, and Z, then you can go ahead and map you basically make them joint rotations. So X, Y, and Z, red, green, blue. X is equal to red, green is equal to Y, and and Z is equal to blue. There you go. So we just connect the rotation of joint to those values. Okay, let's go ahead and bring up the hypergraph and give that a shot. We'll go Window, Hypergraph Connections. Oops, there we go. And we're going to take the IK up arm, or the L up arm, LFK up arm, and LIK up arm. Let's just regraph those. So we have them all. Here's the IK up arm joint. There's the FK up arm joint. And here's the L up arm joint. Okay. Now we're going to create the the blend colors node. So we'll go to rendering, create render node, click on utilities, and you'll see the blend colors right there. So we'll click on that, close this, and you can see it's rebuilt the graph and it's put the blend colors right over here. So we'll take the IK up arm again, we'll take the FK up arm, move that over, grab all three of these, like so. And what we're going to do, basically, if we double click on this, you can see what we've got. Or if we look at the attribute editor, we've got a blender value, color 1, and color 2. So which order do we connect things in? Well, the way the blend colors works, if the blender value is set to 0, then color 2 is what's going to be output. If it's set to 1, then color 1 is going to be the output. Why it's set that way? I do not know. But knowing what we've done in the past with the switch controls, where we could create a enum type value, we're going to create something for switching between FK and IK with two values, FK and IK. And when there are two enum attributes to choose from, the first value is 0 and the second value is 1. So if FK is 0 and IK is 1, then we want to make sure when the blender is 0, we get the FK controls, which means we're going to plug the FK into the color 2, because when blender is 0, color 2 is what's picked. So we're going to drag the LFK up arm onto blend colors 2, and we'll just connect the rotate to color 2, just like that. Then we'll do the same thing with the IK up arm, and we'll connect the rotate to color 1. Let's go ahead and rebuild our blend colors control, and there we go. We can see it. So now we want to connect that to L up arm. So we'll pick those two, rebuild. There we've got our blend colors. And we're going to have the output of blend colors right here, left display, show non-keyable. Output goes into the rotate of L up arm. So if we were to take the IK arm here and look at blend colors, we have a blender value of 0 right now, which means the FK should be controlling this arm. So if we do that, you can see it is. And if we go back to our blender and we just sort of dial this back up to 0, we can now have the IK control driving it. See how that works? Just like that. Pretty cool. So let's set the rotation of this guy back to 0, like that. Now when we look at this, we don't want the animator to have to keep going down to the blend colors to blend between these two values, right? This is, again, the whole thing about making things simple that you see we'll do over and over again. We want to make a control that's easy for the animator to find that will allow them to blend between the two controls here. So what I'm going to do is actually go here under All Anim, and I'm going to make a group. We're going to call it Settings Anim, and this will be where all of the settings for FK-IK switching and all that kind of stuff sit for the animator. So it's all in one place and it's easy for us to find. We'll just go Create, Empty Group, and we're going to call this Settings _ Anim because it's animatable. And we're going to parent this directly to All Anim right there. Okay? Now, we don't need any of these translations or visibility or anything like that on this, so we're going to right mouse button on them in the channel box, and we'll lock and hide them. We don't want to see them. Okay? And we're going to add some attributes. So let's add an attribute for the left arm. We're going to add an attribute, and we will call it LArmState. It's going to be a data type enum, because we're going to go between FK and IK. Like that. And again, you can do this as a float so the animator can blend between them. Personally, I prefer to make it so that you just swap back and forth, and it's a lot easier for the animator to tell what they're working in, because they can look and they go, oh, okay, I'm in FK or IK. They don't have to know that 0 means 1 and 1 means something else. Okay? So now we're going to connect the left arm state to the blend colors node. So we'll go to Window, General Editors, Connection Editor. We've got Settings Anim, left arm state. Let's go ahead and pick the blend colors node. You can click on that in the channel box, and that loads it right in here. And we'll choose left arm state to blender, like that. Piece of cake. So now, if we go to our settings anim, we see that we're in FK mode. It should be that the FK up arm drives that surface. And if we take IK up arm and move it, nothing happens. And that works correctly. If we then go to our settings and we switch to IK, it pops. And FK up arm does nothing, but the IK up arm does control it. So we've gone ahead and actually created a connection between the two, and we created an attribute that's easy to find for the animator to work with, and we can blend between them without using any kinds of constraints or anything like that. But we have to do the same thing for the lower arm as well. So let's go ahead and bind the lower arm rotation and translation. Okay? Now we could go and do the exact same thing in the hypergraph like we did before, but that takes a lot of time, and as always there's quicker ways and easier ways to do it. So you'll find on the animator regging shelf there's a Mel script button up here called blend, and what we can do is use this to automatically create a blend between the two controls. So let's go ahead and set this up for the lower arm. We're going to click on that, and what we want to do is take our object 1, which is what the value is going to be when it's at 0, which will be the FK lower arm. Then we're going to take the IK lower arm. Then we'll click on our target object, which is the lower arm, and we want to pick an attribute for this. We're going to use rotate. And the driver that we already have set up is going to be settings underscore anim dot l arm state, because that we want it to be the exact same control. So if we click go, what that does is automatically hooks up the lower arm. Let's select that and go to the hypergraph. You can see that hooks up the blend node automatically for us, names it correctly, and connects the lower arm and the settings to it, all for us automatically. Okay? Now we want to hook up the translate as well, because remember, the arm needs to be able to stretch, and we're doing all of our stretching with translation. So we'll just type in translate for the attribute, and click go. And that hooks up the translation with the blend node as well. Okay? So, now we need to do the same thing with the hand. So we'll click the FK hand, the IK hand, L hand, rotate, like that. We'll leave the settings, click go, and now the FK hand should be driving that correctly, which it does. And now we just need to set up the translate by typing in translate and click go again. So now we've got an FK and IK system that can stretch, can rotate, we can swap between the controls using one control, FK to IK, and it'll work with the upper arm, the lower arm, and the hand. Let's definitely save this version. File, save scene as. We're going to save it as version 5. And so our next step is to set up the arm rigs so that they actually work as expected using the FK and IK controls. So let's start off with the FK arm rig and add some controls to make it easier for the animator to work with. First thing we want to do is add some NURB selection controls, kind of like we did on the neck and the torso that we can see here, because right now if I go to try and select the FK arm, I'm not sure what I'm grabbing. So let's create a NURB circle. Create NURBS primitive circle, just like that. And there it is. And we're going to go ahead and rotate it about 90 degrees that way. Scale it down a little bit, and then do modify freeze transformations. So it's sitting over there in space. Now we want to add the circle and make it the shape of the up arm, just like we did on the body here, so that when you click on a circle you actually get the torso joint. We're going to do the same thing on the arm. So we select the circle and then select the FK up arm, and we go over here to our shelf and we pick on the parent shape button, which goes ahead and adds it right over there to the object. Now obviously we want to make it look a little bit nicer, so we're going to go ahead and switch into component mode, switch to a front view here, and just reshape this a little bit so it fits better on the arm. So grab those points, translate them over, scale them down, and move them back like this, and maybe scale them a little bit this way. And again, just as last time, you can always change this to be exactly how you want and change the shape so it looks exactly like what you want it to look like. I kind of prefer these little sausage shapes just because they're easy to select and easy to see, and we can select from both the top and from the bottom. Okay? Now, we want to do the same thing for the lower arm. And just as before, remember if we pick this one and then we try and do that on the lower arm, so we have NURB circle 1 and the low arm, and we add the shape, it's actually an instance, so that if we change the shape of this guy right here, it's going to change the shape of the upper arm as well, which we don't want to do. So, instead what we'll do is we're going to duplicate the NURB circle, delete the original one, then select the new one and the lower arm shape, and then go ahead and create that. Then we'll go into our view here, and we will scale this a little bit more, move it down, maybe go back to this one, and translate some of these points over a little bit to try and get it to fit along the length of the arm. There we go. So we've got the upper arm, and we've got the lower arm. Now the next piece we need is for the hand. So we're going to not go exactly from this NURB circle here for the hand. We're going to create a brand new one for that. And so we'll go create NURBS primitive circle. And do the same thing we did before, just sort of scale it, rotate it 90 degrees, modify freeze transformations. And then we'll take this and the hand control. So NURB circle 3 and LFK hand, click on the shape button again, and there it is. Go into our front view, and then again, let's just position these points so they make a little bit more sense for the hand. Maybe scale it down, pull it back a little bit, down, back, like that. And there we go. Now we've got our hand control. So let's delete these other NURB circles, get rid of them, go back out of component mode, and we've got FK controls that we can now pick and use to act as our joints, like that, for the hand. Pick, walk down, and it all works. Cool. Now remember, part of the FK control was to have an orient control up above it so we could actually orient the FK with the body as we spin the body around. So what we're going to do is add that, and we will do it by importing one of the nodes here. If you go into your icons in your examples folder, you'll see that there's something here called the circle arrow 1. So we'll grab that, and this is what we get. This little circle arrow 1. This is going to be our shoulder control. So we want to use this, or sorry, our orbit control. So we're going to go ahead and take it and position it over in the same point as the up arm. So if you do show polygons to turn that off, snap it to the upper arm, show polygons, turn it back on. Then we can simply reorient it, so maybe 90 degrees or negative 90 degrees in Y, scale it down a bit so it's easier to see right there. And notice the arrow will always show us where it'll be oriented along, like that. So when the arm is flat, you can't really see it, but if we bend the arm down, we can definitely see that, hey, the orientation is this way, or if we rotate this way, we'll be able to see that the orientation should go like that. So let's freeze the transformations, modify freeze transformations, so that's set out to 0, and then we're going to rename this to L up arm orient, like that. Now we want to check the rotation orders here to make sure that it's correct, and because the Y attribute here is going to be the one that's doing most of the driving, we want it to be exactly the same as the torso. So it makes it easy to copy the animation if we need to. So what does the torso have? The torso control has a rotation order of ZXY. So we'll do the same thing on L up arm orient, ZXY, like that. There we go. Now let's go ahead and parent the arms. So we'll grab L up arm group, FK up arm, IK up arm, parent all of that to L up arm orient. So if we take L up arm orient it will move the entire thing over. We have to parent L up arm as well, under there. Of course, L up arm goes under there too. Cool. Now we can select L up arm orient, and we can rotate the whole thing, and the entire arm moves. Great. Let's go ahead and save this. File, save as. We'll call this arm rig v6.ma, and let's go ahead and add some length controls to the FK arm. Thanks to the script that we've got, adding length should be pretty easy to do. So we'll just grab the FK up arm like this, and then we'll go and we'll find our length button. So SDK length, click on that, choose translate. Would you like to scale any child geometry? No, we don't, because we've already got our child geometry controlled correctly. And we scale, and voila, that moves correctly. Yay! Do the same thing on the lower arm. Translate. No. There we go. Done. Cool. We've got our FFK controls finished. Let's go ahead and move on to setting up the IK controls. But first, we must save again. Save scene as. And let's call this number 7. So when creating the IK controls for the rig, we're basically going to follow the same things we figured out while testing the ideas. But the first thing we need to do is make sure the arm is going to bend correctly when we create the IK arm. So what we need to do is go to the lower arm, and we need to select it, rotate it a little bit, and then go under skeleton, set preferred angle. And then we can rotate it back. And what that does is just basically tell the IK solver that when it tries to solve, when the arm gets shortened, to just go ahead and bend the arm in that direction. Otherwise, it wouldn't know what to do. So let's, instead of making the elbow control for our IK system a locator, we'll bring in an actual NURBS curve. And by doing this, we'll make it easier for the animator to turn on and off their animation controls by going show NURBS curves, and then everything's gone. So show NURBS curves, turn them back on, and choose File, Import, and we'll go to the icons, and we're going to look for curve loc. So it'll make a locator that looks like a curve, or a curve that looks like a locator. And there it is, curve loc right there. So let's go ahead and position it so it is in the same place as the elbow. So we'll just put on Move Tool, go Show, NURBS